In this video, I want to have a look at how we can find the equation of any line that's passing through the intersection of two other given lines. So what that looks like if we have two straight lines and we know their equations. So the equation of one of the lines is going to be a1x plus b1y plus c equals 0. So a1, b1 and c, that should have a 1 on it, sorry. That's c1 and c2. They're all numbers. And the equation of our second line, our L2, is a2x plus b2y plus c2 equals 0. So we know those. Then any line passing through the intersection of those, and there's infinitely many of those as long as they pass through that point there. So there's just a few examples. Any line that passes through there is going to have this equation. So it's going to be the equation of the first line plus k times the equation of the second line is equal to 0. And that k is a constant term, so that's a number. So let's have a look at an example. Now, because there's infinitely many possible lines that could pass through that intersection, any question has to give you another piece of information as well. So this question says we want to find the equation of the straight line that passes through the point minus 3, 4. So that's our extra piece of information. And we want it to pass through the intersections of the lines 2x plus y minus 5 equals 0 and x minus 3y plus 1 equals 0. So the first thing we're going to do is it's going to be the equation of the first line plus k times the equation of the second line. So we'll write that down. We've got 2x plus y minus 5 plus k outside of x minus 3y plus 1 is equal to 0. Okay, so if we know that the line passes through the point minus 3, 4, then those values for x and y have to satisfy this equation. So what we're going to do, we're going to substitute those values in here and then rearrange everything to find the value of k. So we're going to have 2 times minus 3 plus 4 minus 5 plus k outside of minus 3 times 4 plus 1 is equal to 0. Now if we figure out this whole bit here, that'll give us minus 7. And if we figure out this whole bracket here, that ends up giving us minus 14. So because it's k times that, we're going to have minus 14k is equal to 0. So now we need to solve for k, so we're going to add 7 to both sides. But minus 14k is equal to 7, and then divide by minus 14k, and we end up with k is equal to minus a half. So now we know the value of k, so we're going to substitute that back into this first line here, and then simplify everything down. So we're going to have 2x plus y minus 5 minus a half outside of x minus 3y plus 1 is equal to 0. So this is the equation of our line that passes through the point and through the intersection of these two lines, but it's really messy right now, so we're just going to rearrange it. To get rid of this fraction, we're going to go through and multiply everything by 2. And in the same step, I'm also going to expand out. So this minus 1 times everything in the bracket. So we're going to have 4x plus 2y minus 10. And that gets rid of that. So we've expanded that out. And then expand out your minus 1. So we'd have minus x plus 3y minus 1 is equal to 0. And the last step is just to collect like terms. So 4x minus x would give us 3x. 2y plus 3y gives us 5y. And minus 10 minus 1 would give us minus 11. And we've got our equals 0. So 3x plus 5y minus 11 equals 0. That straight line will pass through the point minus 3, 4 and through the intersection of these two lines. The second example that I want to have a look at, the extra piece of information that we're given is actually the gradient of the line this time. So we want the equation of the straight line with gradient 2 that passes through the intersection of these two lines here. So we start off the same way by writing it out into our formula. So we've got 2x plus y minus 1 plus k outside of 3x plus 5y plus 16 is equal to 0. To find the gradient, we need to rearrange this into gradient intercept form. So what we're going to do is we're going to expand this out and then collect all our x terms together, all our y terms together and our constant terms, and then we can rearrange it. So expanding out, this first bit will just stay the same. And then we've got plus 3 3xk plus 5yk plus 16k. Then if we collect together and factorize out, so with these x terms here, we're going to factorize out our x and we'd have 2 plus 3k x. Then we've got our y terms, so we've got a y here and a 5yk. So we're going to have plus 1 plus 5k y. And then we've just got our constant terms on the end, so we've still got our minus 1 plus 16k. All right, so we've factorized it out with collect like terms. Now we need to get this whole y term on one side of the equal sign. So we're going to subtract this and we're going to move these over the other side as well. So we're going to end up with 1 plus 5k y is equal to minus 2 minus 3k. So we've just put our negatives in our brackets, x, and then we've got plus 1 minus 16k. Now we've got to divide by the coefficient of y, which is that whole bracket there. So that's our 1 plus 5k. So y is equal to minus 2 minus 3k over 1 plus 5k x plus 1 minus 16k over 1 plus 5k. All right, so this whole term here, this whole coefficient of x, that's our gradient. And we know up here that our gradient is 2 for this line. So we're going to say that this whole thing is equal to 2. So we're going to have minus 2 minus 3k over 1 plus 5k is equal to 2. Now we need to solve this for k. So we're going to multiply everything by the denominator of that fraction. So we're going to have minus 2 minus 3k is equal to 2 outside of 1 plus 5k. If we expand that out, we're going to have 2 plus 10k. And then I'm running out of room here, so I'm just going to move up into this bit. Then if we pull all our k's over to one side of the equal sign, so I'm going to subtract 10 from both sides. So I have minus 2 minus 13k equals 2. Then add 2, so we're going to have minus 13k equals 4. And then we're going to divide. So we're going to have k equals minus 4 over 13. All right, so we have found the value of k now. To find our equation of this straight line, though, we need to substitute that back into this first line of our equation. So I'm just going to rub this out and start a fresh page. So I've just left that first line of working out there, and I've just rewritten our k equals minus 4 over 13. So we're going to substitute that in for our value of k here. So we're going to have 2x plus y minus 1 minus 4 over 13 outside of 3x plus 5y plus 16 is equal to 0. So we're going to multiply everything by 13. So 2 times 13 would be 26x plus 13y minus 13. We've still got our minus 4 outside of 3x plus 5y plus 16 is equal to 0. So then we'll leave the front bit and we'll expand out this bracket here. So we'll have 26x plus 13y minus 13 minus 12x minus 20y minus 64 is equal to 0. And then collect like terms. So 26x minus 12x will leave us with 14x. 13y minus 20y would be minus 7y. And minus 13 minus 64 would be minus 77. So this is the equation, but there's one more step that we can do to simplify it. And that is that all these coefficients, or all these numbers here, have a common factor of 7. So we can divide through everything by 7. So we'll end up with 2x minus y minus 11 is equal to 0. So that's the equation of the line with gradient 2 that passes through the intersection of these two lines here.